All right, AP Environmental Science. I want to continue here with this second lecture on global warming to finish up these notes in this note packet. So, we just got done kind of talking about some of the evidence that kind of proves that global warming is happening with all these greenhouse gases being emitted into the atmosphere. And in this video, I want to talk a little bit about some of the consequences of global warming. What's going to happen to our planet if this trend continues. And we'll start here with one thing that we kind of talked about in the previous video, which is the Arctic ice that's melting. The big danger with the Arctic ice, and we have lost quite a bit of it recently. 14% has been just the average decline per decade since the 1970s. You can see that here in the graph, where we currently are with our Arctic ice as far as how much area it takes up versus what were back in the 1970s. I mean, it's a drastic difference. But kind of the big fear with the Arctic ice is that we're sort of trapped in this positive feedback loop. One of the things that we learned in the first semester was about albedo. Albedo is the amount of sunlight that gets reflected. Ice, for example, has a much higher albedo than water does or land does. So when that ice melts, it's producing, or either it's producing water when it melts, or it's uncovering land, which is going to have a much lower albedo. So what ends up happening is, again, when those temperatures rise, when there's global climate change, it causes that ice to melt, and then that creates darker conditions, right? It creates darker ocean water. It creates land, and that material, that surface area that's darker in color is going to absorb more heat, and that causes temperatures to rise even more. So we have this positive feedback loop that we're kind of stuck in. And that's kind of one of the big problems with the Arctic ice is we can't seem to get out of this trap of this positive feedback loop. Another consequence of global warming is permafrost melting. This is a video that I showed last week. You guys hopefully watch this. If you haven't, make sure you do. But permafrost melting is again another one of these issues with a positive feedback loop. As the permafrost melts, and 20% of the Earth is covered in permafrost. Most of it's in the tundra of Russia and Canada. But as that permafrost melts, greenhouse gases get released, especially methane. There's a lot of organic matter that's in this permafrost, and there's bacteria there. So when the permafrost melts, it actually creates an anaerobic environment, and these bacteria start producing methane, and that gets released up into the atmosphere. So again, as the temperature increases, it causes the permafrost to thaw. That permafrost releases greenhouse gases, and that causes more global warming. So again, we have another positive feedback loop that's very problematic and really difficult to get out of, all because of the permafrost melting. Another consequence is sea level rise. We're seeing sea levels increase, quite a bit. Think of sea level rise. Think of it like this. Imagine that you have a puddle of water, right? Let's say it's on your desk, okay, a little puddle of water, and you put an ice cube in the middle of it, and just let it sit for a half an hour. As that ice cube melts, that puddle is going to be expanding, right? I mean, that's kind of what's happening to the oceans. This is called thermal expansion. We have a lot of people who live on land that are living within 3 feet of sea level. So as those oceans are expanding, due to uh, whether it be ice caps melting or ice sheets melting, whatever it is, you're going to end up getting a lot of this water that intrudes the land. Coastal areas, islands are at major risk of flooding. Things like saltwater intrusion, all of those things can be problematic when you have sea level rise. Habitat loss. Probably one of the best examples of habitat loss is coral reefs. Here, for example, on picture on the left, you're seeing kind of a healthy reef. And remember, healthy coral reefs um, depend on sunlight, because they have an algae that, those corals live with an algae that's symbiotic. So as long as there's no sea level rise, then that water or that sunlight can penetrate down. The corals can get that sunlight and they can be healthy. But imagine if the sea level goes up. Imagine if ocean levels rise, then the amount of sunlight that can penetrate down to those corals is now altered. So that algae can't get that sunlight that they need. The algae might die. They might leave the coral, and that's going to destroy the whole entire reef. So coral reefs are really fragile, and sea level rise definitely has an impact. This can lead to coral bleaching, which is again is when the algae actually leaves the animal, leaves the coral, and this can occur a couple different ways. If they don't have enough sunlight, if there's temperature change, if there's a pH change. We'll talk about that more in the lecture tomorrow. But coral reefs are really, really fragile, and they are at major, major risk, again, due to global warming and some climate changing conditions. Food chains and food webs. A lot of food chains and food webs can be disrupted due to global warming. A few things that can occur, especially when you have animals that are stressed due to temperature. Remember we talked about like optimal ranges of living conditions for animals. A lot of times when there's thermal stress on the animal, the reproduction cycles don't work as well. Mating seasons get disrupted. Certain animals are used to breeding, let's say in the spring or the fall, and that's all temperature. Um, it's all governed by the temperature. So if temperatures are changing, then animals are getting confused on when they should mate or when they shouldn't. Egg hatching times get affected. A lot of times, temperature has a major impact on whether or not eggs will hatch. So, if there's changes in temperature, that can have a drastic effect on that. Insect larvae. A lot of times, the different stages of the larval life cycles of an insect, again, are temperature dependent. So, these things all can be impacted by global warming. Air circulation is another consequence. Hadley cells. We talked about air rising near the equator, and that air cooling and dropping near 30 degrees north and south, and those are like the major currents of air circulation on our planet. They drive a lot of weather patterns all around the globe. So if those things are being impacted by global warming, that's going to have a major impact on climate, local weather patterns, storm intensity, that type of thing. Heat waves, we global warm. I mean, we've been seeing this. We've been seeing longer periods of warm weather. This has a tendency to do a lot of damage to soil. If there's no rain coming down, the soil gets very dry. It can erode. It can weather away, and then that would be bad for crops. Obviously, that would also mean that we have to irrigate more. If you have, let's say, an area that's used to getting an annual amount of precipitation, but now it's not getting that, so you have to irrigate. That means you have to deplete aquifers, and that can be problematic as well. We've talked about that back in our water use unit. Same thing with cold. Cold spells. If you have climate change, don't always think that climate change means that it's going to get warmer all the time. It just means that the climate is changing drastically. Some places might experience extreme warm spells. Some places might experience extreme cold spells. Now, cold, that could be I don't know, it could be good or bad. It probably depends on where you live. But one of the big issues with cold spells is if there's fewer cold spells, that means that a lot of pests that either could carry disease or they could kill crops. Those pests aren't going to die if it's not going to freeze. Same thing with plant pests. Those like weeds, for example. Weeds get killed by the cold, but if it doesn't get cold, then that can be a problem if none of the pests are going to die. So you'll have to increase your use of pesticides, and we know that that's not necessarily good the environment. Precipitation patterns can change drastically. We can see more flooding, and we can see more droughts. Storm intensities can vary as well. We're seeing a lot more hurricanes now than we ever have before. And finally, ocean currents. The ocean currents are a big deal. If these become altered, again, kind of like Hadley cells and wind currents, that can have a major impact on climate. One of the things that we're seeing right now is up in the North Atlantic. This is the North Atlantic gyre. Normally that this is kind of warmer water that flows north, but because of all of those ice caps melting, like especially up here in Greenland, it's actually causing it to be a lot colder. So what's happening is England, up in here, is being impacted by that. Instead of this water being nice and warm that travels by England, it's now becoming much colder, all because of the ice that's melting up there near Greenland. So Europe, and especially Northern Europe, like in England, they are experiencing some colder than normal temperatures, all because of just the way the ocean currents are circulating and picking up all that cold water. All right, guys, that is it for the notes for today. Make sure you check your Buzz agenda for your homework. All right, take care. Have a good day.